Hello everyone, this is a quick demonstration of a cloud computing project. We are group 19 and our project name is Modalysis. Next slide. So we are a team of 5 members, Ekant Satyayan, Yash Desai, Anta Tripathi, me, Yashwardhan Rungta and Swami Chatterjee. Next slide. So the flow of the demonstration is as follows. First we'll talk about the project, followed by its architecture. We'll show you the front end of the deployed architecture and its functionality. Its functionality includes the CRUD function that we are performing and the user access management. Additionally, we are using external REST APIs like Discord Webhook and NLP Cloud. We have integrated this into cloud using MongoDB. Furthermore, we are also using hash-based authentication for user password protection. The whole project is deployed on cloud, on Heroku as well as Google Cloud platforms. So the title of our project is to create a Flask application which uses state-of-the-art machine learning model BART to perform text summarization with a user management system. There are two types of summarization strategies: extractive and abstractive. Extractive strategies are recently developed and have been only made possible because of transformers like BART. BART is trained using corrupt text like noise and corrupt text functions and also learned on model to reconstruct the original text.
We are using a front end from which we are interacting with Google App Engine through get, post, put, and delete API requests. And we are using external API request, Discord, and NLP Cloud. And we are using MongoDB as our backend database. So this is our front end of the application. This is the landing page where user can log into the system as well as they can create a new account. And we are implementing CRUD operations, which are create, read, update, and delete. So these are the screens for user sign up. The users can sign up through the left screen, and there's a create user option for administrators. For read operations, we have user login. The user can log in, and administrators have another option to view all the users. So this is implemented using get request. For update request, we are using the update user functionality where admin can update details for any of the users, and they can assign a role as well for admin or an application user. For delete function, we are using a delete REST API in which user administrator can update an email ID and they can delete the user.
So now after the user has successfully logged in, the first thing that is visible is our deployment of the BART summarizer, which Yashwardhan just explained. So when you click on the text summarization button, the app will take us to a new page where we can just copy paste our article or upload a text file of the article. Now clicking on the submit button, the app will call the BART model using the NLP model external API and print the summary for us. So this is how the result looks like. Another external API that we have implemented is the Discord Webhook API. So basically, when the model generates a summary of a given article, we store the same into a result variable. This result variable is directly sent to our Discord server as a text file using the unique webhook ID of our Discord server. So this is what the text file that we have received on our Discord server looks like.
Yeah, thank you so much. Here, so our system usage or no external data based on cloud, that is MongoDB, to securely store our information. The NoSQL databases are basically non-tabular databases and store data differently than relational tables. In NoSQL databases, data can be stored differently based on their data model. Here we are using key value pair type of saving. We have used MongoDB by using a MongoDB cluster via MongoDB Atlas. MongoDB Atlas is a hosted database service that allows us to choose our database size and get a connection string through which it's integrated with our application. We have integrated the MongoDB with our application to Python, which Python provides a default driver named PyMongo to integrate it with MongoDB. We have our database in which collection tables were there, users and model pickle files. In users, either user login and authentication details are saved, and in the model pickle files for the model instances have been saved. So here we have implemented hash-based authentication as well. We are using Python passleaf hash library to import the pbkd f2 sh256 function for hashing and salting the passwords. We are can you go to the next slide, please, Akansh? We are using here MongoDB Atlas M0 sandbox, which is a free edition with cluster size 512 MB. We have taken this kind of free database as our project scale is not that large, and the number of users are also very less in number. So yeah, that's all from my side. The next slide, will be explained by Andhra.
So one of our deployment is on Google Cloud Platform. Among various services which they provide, we have primarily selected Cloud Compute Engine, App Engine, Cloud Storage, and Cloud Source Repository to deploy our app. Next slide, please. So this is the architecture diagram or the flow diagram of the whole deployment which we have done on GCP. So if you see, we have a developer on the extreme left, and the developer make changes which is committed on the Git repo. And the Git repo is again one of the primary source of the whole deployment code which we are having, which is again then fetched into Google Cloud Source Repository, which is the source repository of the code in the cloud platform. This cloud platform again is connected to the MongoDB server because the whole database access is given to MongoDB Cloud Server, which is hosted on Mongo Atlas. Now, when we trigger build the code which is on the cloud source repository, it goes to the app engine, and the app engine builds the app. If the app is deployed properly and published, then a Flask server is started, and we can access the app via the Flask server. But if it is not deployed properly, then it goes back to the developers to make changes and do the steps before. So we have, as you can see, two external API. One external API is the NLP Cloud Playground, which is one of the main NLP model which we are using in the app engine to get the text summarization. Another external API is Discord webhook, which is basically part of the Flask server which we are hosting. So once the text summarization is done and result summary is generated, we can send the summary to Discord using this external API. Not to mention, we have user authentication on the Flask server. So all the user detail goes back to the MongoDB using the hashing function as explained before. Next slide, please. So the second deployment of our app is on Heroku. And it was again done directly from the Git repo. So we basically pull the Git repo into Heroku, and we have proc file, we have WSCI file, and we have requirement.txt file, which helped us to deploy the app on the Heroku, and it was successfully deployed. Next slide. So this is the Git repo for our project Modalysis, and this is the project structure where you can see we have ML model folder, we have static folders, we have template folders for all the important HTML which we are rendering on the Flask app, and then we have user folder which has all the important py files, and here is our route py file, which is basically the route for all the HTML get post requests which we are making. Going back to the Modalysis folders, we have some more important files like proc file, which is used for deploying the app on the Heroku server. We have app.yaml file, which is used to deploy app on the GCP server. And not to mention, we also have WSGI file, which is basically the main file, which is fetching the app from the Flask file. Going back to the main repo, we have Modalysis instance running on GCP, and link can be found right here on the right-hand side top. And if you click that, you'll redirect it to the page which is hosted, and this is our instance running. If you go down, we have our app deployed as well on the Heroku, and if you click there, you will be taken to the Heroku instance. Coming to the README file, our README file consists of project aim. Then we have tech stack describing all the tech stacks which we have used, like Python, Flask, MongoDB, Heroku, HTML, CSS for the front end, and then definitely GitHub for version controlling, and Discord, our external API. So we have given a small brief introduction about what BART summarization is, so that people get familiar about the implementation of the summarizer model. We have also given syntax for local deployment. So if you want to run this folder on your local machine, you can follow these commands to run the app. Followed by that, we have GCP deployment. You can also visit the instance deployed, which is deployed on GCP with this link. And we have elaborately mentioned all the steps here. So you can follow these steps on your own to deploy your own app as well. And next comes our Heroku app, which is deployed on this link. And now I will show you how it looks like. So this is a Heroku terminal, and where you can see that in the build logs, our app was deployed successfully, and I can open the app here from here. And it will take you to the coming back to the Modalysis folder. Here is the deployment architecture of the whole app as discussed in the presentation. Not to mention, we have screenshot of our app as well. To talk about the project requirement, we successfully checkbox all the requirement which were mentioned in the guideline for the project, which is to use REST-based service infrastructure and CRUD operations. So we have used get, post, put, and delete in our Flask app. We have external REST APIs which we are using, like Discord, webhook, and NLP Cloud to do summarization. Then we are using cloud-based database, that is MongoDB cluster. We are serving over HTTPS, which is a secure URL for the deployment. We have also implemented hash-based authentication for all the user information which is getting stored. And we have user accounts and access management, which can be viewed by the admin portal of the app as well. And since we have admin and user, definitely we have role-based policies which can be viewed in the Mongo cluster as well. That's it. You can visit our presentation by clicking on the links below and view this video again by clicking on the YouTube.
I'll discuss about the Google Cloud platform that we have used to deploy our app. As you can see, we have created a project under our name Modalysis. And we have, once we have created this project, we create a VM instance. As you can see, it's up and running. And we have used the zone Europe West 2 as it was closer to our location in London. We used a 4-core CPU with 16 GB of memory. After this, we have created an instance in App Engine, as I'll show you. As you can see, the latest version is up and running, and the instances that I have created are as running as well. Further, we use cloud source repository to pull our GitHub repo, and using Google Cloud Console, we push the code and deploy the app.
This is our MongoDB database. Version we are using is 5.0.6, and the region you select it is Belgium, Europe West region, and as I said before, the cluster we are using is M0 sandbox, and there are 3 nodes, and here we can see in the graph that the graphs are going up and down as users hit the database, and the data are getting stored. And if we go to the browse collection, we have both the collections here, as we explained before, the user table and the model pickle files. And as we can see in the user table, the user information are being stored in no SQL format. So the name is admin1, and the email ID is this as written. And as we can see that we can see the name and the email ID of the user, but the password can't be seen, as we have implemented a hash function in the in this application. So the password is encrypted. It was saving. And if we go back to the database page, so the data in and out here can be seen, like the inwards data count is 397 bytes per second, and the outwards data graph is 13.7 kbps. And if we go to the connect section, as we have mentioned before, that we have connected our application through a connection string. So if we select there are options to select the driver with which we want to select, and the version. Suppose we are selecting Python, and the version need to be selected here. Like we are using Python 3.8. I have used Python 3.8, so I have selected 2.6, and later here we can get the full connection string through which our application is connected with the cloud MongoDB database. So here is the string.
So now we will give the demo of our application. We have 2 roles, user and admin. So I'll cover the admin part of the application. So if we have an admin login, we have admin1 to gmail.com, and if we log into the admin account, it will take us to the admin landing page where admin can manage users in the application. So under manage users, we have 4 options where administrator can view all the users. This is implemented using get API. Here we are fetching all the users existing in the database currently. Now the second operation is the create of user, where we are implementing all the user creation part using post request. So here, if I add 1 user, an administrator can select admin or an application user role. And if the user email ID already exists, our application throws an error for that. So the user is created. We can verify that by clicking on the show all users. This is the latest user which we have created. To update a user, we have implemented put request, where we can check and implement any of the user update. So here I'm updating test1@gmail.com. Now admin can update name or a role for the user. If you're using this wrong email ID, you'll get an error here. The email ID doesn't exist. So it verifies the email ID through MongoDB request. If you use the correct email ID, and if we give the same data, then also we will get an error that entered value should be updated. So here I'm using some new value, and I can update the row. And we can verify this here that the name has been updated. Then the delete request is out using the delete API request. Here we can delete a user using the email ID. Here we're searching the user based on the email ID, and deleting the user. And we can verify this again.
So I'm going to give you a quick demo about the user end of the application. So first of all, as a user, I have the functionality to create an account. So I'm going to create a new account. So I'm going to log back in from the user that I created. So as you can see that we successfully created a new account and we are into the application. So the first thing that we can see is the text summarization that we're performing using the external API. So I'll paste an article below and it will give me the summary of the article using the BART model that we have deployed using the NLP model API. As you can see that we have extracted the summary out of the article using the BART model, and now we can directly send a message to the Discord server that we have created, and it will send the summary as a text file over there. So as you can see that we successfully received the message on Discord. We've also provided a functionality to upload a new file, upload a text file and create a summary out of that. So I can also demonstrate that. So we have uploaded the summary.txt file. Now, as it is visible on the screen that it has successfully read the txt file and created a summary out of that as well. So another functionality that we have implemented on our web page is the About Us page. On the About Us page, you can see that we have the information of all the 5 teammates of the team Modalysis. So we have also implemented the mail to option through which we can easily contact each and every teammate using the simple contact button. And that's it for the functionality of the Modalysis application that was deployed on the Flask server. Now I can log out of the application. So that's it for the demonstration of our application, and you can find the link of the GitHub in the video, and you can always suggest changes and you can fork the GitHub repo.